Good afternoon. We are continuing working with those functions and ordered pairs in our graphing. Today we are doing CO50. I can find the slope of a line that has been graphed. So instead of using the rule of the function to find ordered pairs that go on the line, now we're going to learn how to use the slope of that line to see how we could continue that line. So the slope is how a line moves across the coordinate plane. So remember that coordinate plane is our graph.
Please pardon this interruption. I would like any altar server to please come to the office. We are going to take your picture for the yearbook. If you are an altar server, please come to the office for a very quick picture. Thank you.
Okay, so this is our coordinate plane, is this whole graph. When it says how the line moves across it, that line goes up at the same way, that rule that we followed in our function table. It made that line go the same way, and we could pick a point that would be on the line. If we continued it all the way up to here, we could say what that point was by following the rule. We can do the same thing by finding its slope. Slopes are kind of a big one, especially when it comes time for those math tests. So let's see how that works. How to find the slope, we can say it in several different ways. One way we could say it is it's the vertical change. Vertical means up and down. Vertical change over the horizontal change going across. So if it's vertical up and down, which axis are we looking at? The Y. So we could call it the change in Y. Over the horizontal would be the change in X. So it means the same thing. Vertical is the change in the Y. Change in your vertical is the change in your Y. Change in the horizontal is your change in your X. Both times the Y is on top, the X is on the bottom. Last way, and this is the way that most people will refer to slope as, is it's the rise over the run. So think of a balloon rising up or down, and the run is going across. So we're going to plot the two given ordered pairs and connect them with the line as straight as you can, but we're not perfect. So we're not going to eyeball it and say, well, I drew my line and this point ends up on my line. Because it might not. You might have drawn kind of a messy line, and it might not actually end up on that line. So we don't go by just looking, but it looks like that point would be on it. We have to use the slope. We're gonna find the slope, and we're gonna show the change in the Y and the change in the X. So we're gonna write the rise over the run. As always, when we do our math, we read from the left to the right, just like we're reading a sentence on the paper, left to right. So when we do the vertical up and down, that rise, doesn't matter if it's going up or if it's going down. But when we do the run, that's when we have to say, oh, I always start at the left point and I go over to my right point. So if we look at this first one, we have -4, 2. We're going to plot that on our graph. Then we have -3, 5. We're going to plot both of those on our graph. So right now, you should be plotting those 2 points. First thing you do is you plot your points. Then you draw your line as straight as you can, making sure that it's a line and not a segment. Put your arrows. Okay. This part we've done before. We've plotted before. Here's how we do the slope. We want to find the slope of this line. We're going to go from the farthest left point. So that's going to be right here. We're going to go farthest left point so we can work our way to the right. First thing we always do is our rise, then we're going to do the run. So sometimes we're going to go up. Sometimes if our line is going this way, we have to go down to get to that next point. If we go up, it's positive. Okay? Everything rising up is positive. Anything that goes down is going to be negative. Even if you're not down in negative numbers, because we're going down, we're going to call it a negative slope. So it will be negative. So if your line goes down from your first point to your second point, it is negative. If your line goes up, it is a positive slope. Does that make sense? Aiden?
Where's going down again?
I drew this one as an example of what a negative slope would look like. So that's not what we're graphing right now.
So whoever starts then.
You always start at the farthest left point, and then you look at where your next point is. As you're going to the right, if that next point is above it, it's positive. If that next point is below it, reading from left to right, then it'll be negative. So we're starting at -4, and our first thing we do is the rise. So this one goes up, so I'm going to count how many up. 1, 2, 3. I went up 3 lines, so I'm going to put a 3 on my rise spot, on the numerator part. Now I'm going to count my run. The run always goes to the right, so that run is always positive because we're going to the right. Think about our number lines. Positive numbers go all the way to the right, negative numbers go to the left. We're never going to be going to the left because we always start on the left and we go to the right. I'm going over 1 space. I'm going to put a 1 under it. It's 3 over 1. So we'd read it, for our slope, we'd read it as 3 over 1. That's our slope. Here are the tricky parts that you need to be mindful of. Always do the rise first. Always do the rise first. I have some people who do the run first, and then they go up or they go down. Always do your rise first. So you remember, the rise goes on top. The rise is your first number. Rise goes up or down. Always start on your left. I have people that will start on the right, and then they get messed up about those negative numbers. If we had started on the right over here, we would have gone down and then over. And we would have said, oh, we went down, it's a negative. But it's not, because you have to start on that left side. You always have to put the rise on top, the run on the bottom. Always, always, always. James.
Can we do that next one?
Yep.
Oh, wait.
This one?
Oh.
So let's grab our next one. I'm gonna look and I'm gonna say my order here is 1, 6. Audrey, do you want to come up and grab those 2 points for me? Hello, this is Kate. Yes. Uh-huh. Okay. At the end of the day, okay. Perfect, thank you. All right, bye. Yeah, I put the arrows. All right, so thank you, Audrey. We have 1-6 is way up here. And then we have 5-3 is down here. So 1-6, 5-3, and we have our line. Now we're not just gonna leave it at that. We're gonna find the slope. Multiple steps, just like our last objective. Multiple steps. So first thing we do is our rise. So James, you want to come up and figure out what the rise is?
Did it go down? Okay, because it's always.
Which point are we going to start at? Put the pen on. Yep, we always start on the left. Yep, so we have to go down. Okay, so right over to the side, what it is. Nope, just do that part. So, go sit down. If we look at what James wrote, oh, what did you catch, James? At the last moment, he realized, oh, I went down. And whenever we go down from the first point, we have to put that negative symbol. So when we go down, we're putting the negative. So that's why this 3 over here, we went up, it was positive. This 3 over here, we went down, so it's a negative. Who can do the run for me? Kate.
Please pardon this interruption. If you are in the orchestra, could you please come to the gym? If you are in band, can you come to the gym? If you are in orchestra or band,
So
please come to the
we
gym
went
for a quick
over
picture.
4,
Thank you.
so our run is 4. So our slope for this line is negative 3/4. Okay? You look confused. It's really not. But one thing I talked with Mr. Schultz about, remember the last test when I passed it out? I said the directions didn't say to simplify, and I was going to mark people wrong for not simplifying, but the directions didn't say, and I was not wanting to, I was tired and crabby, and I didn't want to take it out on you, so I gave you credit. And he said, Mrs. Gregory wants you to put periods in capital letters at the start and end of sentences, right? And she takes off points if you don't put a capital or a period. Did the directions say put a capital or a period? Did the directions say it on your paper? No, you just have to do it. He said, oh, we get hardcore in 7th grade. Directions don't say to simplify. Even if the directions don't say it, you have to simplify. So can either of these slopes, can we simplify? No. Will you get slopes that you have to simplify? Yep. So your final step is always checking, can I simplify this slope? Can I divide the same number out of the top and the bottom? Does that make sense? Chris?
I thought slopes were like the curved lines on graphs.
I understand why you would think that, but it's not. So those arcs on the graph that have a curve, that's not what the slope is. The slope is always the rise over the run. So these are these vocab words that we're learning. That's going to help us as we get into the harder math. So a slope is always rise over run. Aiden? Oh.
Do you go like up first, then to the side, or?
When you plot a point?
Yeah.
So when we graph, remember it's always X then the Y for our ordered pair. It's always that alphabetical. X comes first in the alphabet, so X is our first number in our ordered pair. So X is always the horizontal line. So you find where the X is, and then you find where that Y would be. So if we look at this one, we're going to find our X, which is -3. And then we go up or down to our y. Our y is -3. So you always go to the x and then you go up or down to graph it. Any other questions about the graphing? And I can go through stuff with you when I'm done recording. Chance. The bottom. Evelyn, did you get the top written in? So once you have these done, you just have to think these through. You're designing a water slide. Which of those 6 slopes that you found do you think would be the best water slide? Okay, and be able to defend yourself. I think this would be a great water slide because be able to answer why would that be a really good water slide? If we have a slope that's like this, is that going to be a really good water slide? I don't know, my 5-year-old's like a little bit more of a challenge, right? So you just have to think it through. What does it mean? You're designing a wheelchair ramp. Which slope above would be the best? Well, we might not want the steeper slope because that poor person on the wheelchair might get hurt trying to climb up it or go down it. They might want the more gradual slope, right? So now you think you're designing a staircase. Which slope would be the best? You have to think it through. Which one would look like a good staircase? Which one would look like a good water slide? Which one would look like a good wheelchair ramp? James.
Is it like the graph line that we have? Yeah.
Okay, so look at the line that you drew with which, and then write what slope it is for that one. Any other questions for this one? All right, for my friends at home, we hope you are well. We hope to see you soon. Have a wonderful day.